All right, everybody, I left you here. And the question was, how do you make paranitroaniline? Because what I told you was your initial instinct of benzene, nitration, reduction, and then trying to nitrate this, to get to here, wouldn't work. Because the intermediate you would actually make with that free amine and all of that acid, the first thing you would do is protonate that amine, which makes this a meta director and one hell of a deactivator. All right, so that won't work. That doesn't mean we're completely up without a rope. We just have to think about this a little differently. I'm going to go to here, all right? Hopefully, between the last video and this video and what we did a couple minutes ago, you can remember how to get here. And the thing I want you to remember is this. Remember this thing? I thought you would. So, what we've got here is our ortho-para-directors. And we know that the NH2 is an ortho-para-director. And remember, that's the structure we want because we're trying to get to paranitroaniline. But we know we can't use the amine because it'll protonate if you give it half a chance. But looky right here. I don't know why that just used the highlighter. But looky right there. This is the amide. And more specifically, it's the amide with the nitrogen attached to the ring. Meaning it is still an ortho-para-director. And because you've tied up some of that amine with the carbonyl of the amide, it's not going to protonate as easily. So here, I'm just going to flip on over to this page where I have a little more room. And we're going to show this. Again, I'm not going to show you how we make the aniline. Go back a video or two, or just go back earlier in this one. So what we want to do here is we want to react this aniline with the acetyl chloride. The acetyl chloride will work, so will the acid anhydride. Either one will get the job done. Doesn't matter which one you choose. And what you're going to make now is this. All right? There's what you're going to make. Now, this is important for two reasons. One, it allows that pair of electrons to push around the ring and generate those lovely ortho-para locations, and favors a cation formed on this carbon by resonance through the nitrogen. But, and this is important, you might be asking yourself, what prevents this structure from picking up another proton from an acidic environment? Well, here's what. This won't happen. This won't happen at all. And here's why. When you've got this, remember, because it's an amide, that pair of electrons exists in a resonance form going through the carbonyl oxygen. All right? Now, you might be asking yourselves, well, which one is it? Is the pair of electrons pushing through the ring making it an orthopara-director? Absolutely. Is the pair of electrons in some sort of resonance or hybrid form through the amide? Yes. They're both happening at the same time. Electrons can really get around. But the thing to remember here is what they are not is available to pick up a proton. So what we do to make paranitroaniline is we start with aniline, we react it with acetyl chloride. I just like to get to the point. Anhydrides take longer to react. Acid chlorides are a lot thirstier. Yeah, I do that in the entirely wrong place. Let's just get rid of that and try it again. And now we can nitrate the crap out of this. Because the amide makes that nitrogen immune from protonation, and this whole group here is an orthopara-director. So the product we get here is this. All right, now the final step of this, which you can ask yourself is, I don't want the amide. My target molecule is this. How can I get that? Well, how do you go from an amide to an amine? Base, water, and heat. We'll cleave the amide right off and bring you back to the amine. All right, I know a lot of this is looking scary to you guys, and I'm sorry there's not a lot I can do about that. I'm trying to do more of these examples to make you comfortable with them. Ultimately, what you need to be able to do is you need to be able to know your reactions well enough that when I ask you something like this, you can go, oh yeah, well, I need that to be an amide. I know how to make an amide. Then I can nitrate it. Then I can chop off the amide back to the amine. All right, folks. So I'm going to leave you with one I want you to work on for a little bit. And this is a tough one. I'm not going to lie to you. And it requires a lot of thought. This is what I want you to make. And I want you to make this, I kind of drew that on the exact opposite side of where I needed to, didn't I? Let's do that again. I want you to use this, and I want you to go ultimately what the hell did I have there? Was it an iodine? I think it was an iodine. All right, I'll leave you to it, and I'll see you next video.